concepts of reliability, what is reliability in the last class. So next two classes in this week, today and tomorrow, we are going to discuss basics of probability theory as required for reliability evaluation in past. Then after this, next 2 weeks or 6 classes will be devoted to probabilistic evaluation of generating capacity reliability. Okay, so where you will see various Excel based methods to understand how the reliability evaluation takes place. Okay, so today's part is a review of the basic probability theory. Focusing on the prerequisites. Okay. 2 classes of the prerequisites. It's a revision. It's not exactly prerequisite. It is required, compulsory. It's not a background. You are going to use this while solving problems. So today's part is we have to solve all these 5 problems. Okay, based on the concept of probability. We'll solve as much as possible. Then remaining you solve at home. Solution is there in the PPT. For this two probability review and binomial distribution, I have only scanned the notes because there is no point making a PPT. So I have scanned the notes. Beyond that, everything will be PPT and Excel combined. Okay, first you start with this problem. A coin is tossed 5 times. Evaluate the probability of each possible outcome and draw the probability mass function and the probability distribution function. Now there are 3 concepts here. Okay, we'll solve this problem. First is probability. The second is probability mass function. Third one is probability distribution function. So there are 3 concepts. One is the probability function. So when a coin is tossed, you can have either head, either tail. Right? So what is the probability of head and tail in a unbiased coin toss? 50-50 half. Half. Okay. Now the coin is tossed 5 times. Okay. The number of tosses are 5. So what are the possible outcomes? You can have all heads in all the 5 tosses, 5 heads, or you can have 5 tails, or in between. Like 1 head, 4 tails, 1 tail, 4 heads, like that. Now based on that, we can develop the probability density function and the mass function of probability density function. This is also known as the probability density function, as well as the distribution function is also known as CDF. So this is known as, write down this is called probability density function. And this is known as cumulative distribution function. Write it down. This is the very basic of probability theory. You have a term known as probability, which is number of occurrences and divided by number of sample, the cardinality of the sample. Okay, how many total outcomes are available? Total outcomes are 2, either head or tail. If head, 1 by 2. If tail, 1 by 2. That is probability. And density function and mass function are applicable when there are the number of events are more than 1. Both are details. So what is probability? The probability is a scientific measure of chance. A chance we all do quantitatively, but probability is a quantitative measure. When we evaluate, we compute. That is, it quantitatively defines the likelihood of events. Just write down this likelihood of events. Likelihood of events. Probability means likelihood of events. Mathematically, it is a numerical index that can vary between 0 and 1. So, a probability value varies between 0 and 1, both inclusive. Okay, probability can be 0. Okay. Can you tell me probability of one some event? Which is the probability of one?
Probability of 1.
Any event that has a probability of 1. 100% probability. Yes. So when a person takes birth, he will die. The probability of death of any living being is 100%. What is the zero probability event? The probability is 0. Any example? Zero probability.
Immortality.
Okay. Another natural event. The sun rises in the west. The probability is 0. Okay. Okay. But such events are rare. Very rare where the probability 1 is. So we have a probability value generally 0 and 1. Okay. So the formula is, write down this, probability of success is given by the number of successful events divided by number of successful plus number of failures. For example, your objective is to get a head. So in that case, your success is number of heads, whereas failure is number of tails. So number of heads divided by number of heads plus number of tails. Right? The first point was probability. Write down number 1 was probability. Number 2 is permutations. Okay. What are permutations? So you might have read this in your 12th class, 12th standard as well as engineering program. Okay. The number of permutations of n different items. See, the number of permutations of n different items is the number of ways these items can be arranged. Okay. So it is given by NPR is equal to n factorial divided by n minus r factorial. Okay. So this formula is right, NPR. Both Excel as well as all software, MATLAB, Octet, Scilab, they have functions to compute NPR. You should know how to do that in those software. For Excel, we will see. So probability of NPA is equal to, of course, because n minus n is 0, so it is n factorial. Okay. So that means n different items can be arranged in n factorial ways, provided all are distinct. So all of you, so whatever number of students, it can be arranged. Suppose you are 13 students, so 13 factorial ways can be arranged, provided 2 are not identical. None of you are identical, right? Now, whenever there are like items, like they say some problems like balls, there are 5 red balls, 3 blue balls. So in that case, repetition is there. So in that case, the formula is n factorial divided by the number of repetitions. R blue balls, R red balls. In GATE also probability questions come. Simple small problems like this they come. They ask problems. Write down this formula when there is repetition. When there are items R1 alike, R2 alike, R3 alike, then the permutation is this. Okay. And factorial divided by R1 factorial R2 Did you write this? So point number 3 is combinations. Now this is very important from objective. Our objective is reliability evaluation of power systems. So this combination is more important. Okay. So what is combination? It is the number of different. It is the n number of different selection of R items without regard to the order of arrangement. So I select. Suppose I select 3 of you. I select out of 13. I select 3 of you. 3 can be arranged differently. Okay. But in combination, I don't care about that. Group means this is a group. Group of three students. Okay. But in permutation means this 3 can be arranged again in 3 different ways in different order. Okay. So combination means only the grouping. Okay. So what is the formula for combination? So combination means without rearrangement. So combination is written as NCR, which is equal to NPR divided by R factorial. Because we are leaving out the arrangement of R items. So it is N factorial divided by R factorial, N minus R factorial. Okay. Factorial, you know what is 5 factorial? What is the gap? 1 into. Right. Suppose I say, so here is there. Did you write the formula? So now, some example. So you compute yourself. Now it's a revision. It's a revision of the permutation combination. So n is 4. Total number of items are 4. N is 4. Now you take 1 at a time. So how many ways you can arrange it? 1 at a time. 4 ways. So it is 4 P1. What is the formula? 4 factorial divided by 4 minus 1, which is 3 factorial. So 4 factorial. This means equal to 1 into 2 into 3 into 4 divided by 4 minus 1, 3 factorial. It is 1 into 2 into. So it is 4. Right? Now, what is the combination? So you will divide 4 factorial divided by 4 minus 1 factorial and 1. 1 factorial is 1. So you divide 4 by 1. So these two are equal, identical. Okay? For 4. When you take 2 items, so in that case, this becomes, how much this becomes? 4 factorial divided by 4 minus 2 factorial, which is equal to 1 into 2 into 3 into 4 divided by 1. 4 minus 2 by 2 by 1 into 2. So this is 1 2 into 3 into 4 divided by 1 into 2. So that means only 3 into 4 is 12. But when you take combination, you have to also divide by 2 factorial. Okay. So that means 12 divided by 2 factorial. So this will be 12 divided by 2 factorial. This 1 into 2, so this is 6. Okay, clear? Similarly, 3 and 4. So 4 factorial divided by 4 minus 3 factorial. Okay, which is 1 factorial. 3, right? 4 minus 3 is 1 factorial. So 1 into 2 into 3 into 4, which is 24. But here again you have to divide by 3 factorial. What is 3 factorial?
1 into 2 into 3. 6.
3 factorial is 6. 6. So it is 24 by 6. So 24 by 3 factorial, which is 6. Similarly, here also it is 4 factorial divided by 4 minus 4 factorial. Okay, 0 factorial is 1. That's the definition. 0 factorial is 1. So this is 4 factorial 24. Again here you have to divide by 4 factorial divided by 4 factorial. So that is the right. So compute the other one, which level? Yourself. Wiki. Okay. So for this, leave some space. You will do that at the end. Okay. You will compute yourself with calculator. Okay. Or else you compute this part. This is 7 P3 first you write down the formulas. 7p3, what you write? 7 factorial divided by 7 minus 3 factorial, right? This one. 7p3, separately you write. 7p3 is equal to 7 factorial divided by 7 minus 3 factorial. Okay? Right? Then 7 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7. Whereas 7 minus 3 is 4 factorial. So 1 into 2 into 3 into 4. So what remains? 5 into 6 into 7. So check that 5 into 6 into 7 should be equal to 210. Is it? 5 into 6 into 7. 30 into 7. Yes, it is 210. Now for combination it will be 7 factorial divided by 7 minus 3 factorial and 3 factorial. So you have got 210 divided by 3 factorial, which is 6. 210 divided by 6 is 30. Okay. So this is the third point: probability, permutations, combinations. Some theoretical background. Sometimes it is possible to determine the probability of an outcome. So here the keywords are probability of an outcome. In our case, it will be whether it is an on state or off state. That is the outcome. From simple knowledge of geometrical design of the object as of the mathematical specification of the problem. Okay. However, in most engineering applications, it is necessary to obtain experimental evidence. So mostly we do this by means of experimental evidence. Okay, we need data to find the probability. From design it is very difficult to obtain the probability. Okay. So now you write just an idea. For large systems, destructive testing is not possible. Following alternative methods are applied. So you cannot find the probability by putting something into destructive test, just like car or whether it will fail under impact or not. Only a few impact tests can be there. Otherwise, you have to simulate. So we can simulate. You cannot say how much power system is reliable by simply putting faults into the power system. Okay, it will damage the components. So rather, we go for simulation method. Okay. So the two alternative methods are: one is the device or the system is subdivided into one or more hierarchical levels such that the probability data for the lowest hierarchical level is most easily obtained. Hierarchical level, different hierarchy we make. The required data is established from actual operating experience, past data. Okay, not direct feedback from the user, from the designer or manufacturer, so that the continuous assessment concerning reliability of components can be made. Now this one we will see later. This is related to power system only. Unavailability we have already written that. So 3 points we have written: probability, permutations, combinations. Now the fourth point is independent events. Okay, fourth point is independent events. So two events, probability, when they are said to be independent. Okay, two events are said to be independent of the occurrence of one event if the occurrence of the one event does not affect the write down. This is the definition you write. If the occurrence of one event does not affect the probability of the occurrence of the other event. One event does not affect the probability of occurrence of the other event. Assumption of event independence will lead to optimistic assessment of the system reliability. Optimistic means better reliability, because we are saying that both are independent. So we can multiply their probabilities. Okay? Next. Two events are said to be, for point number 5, two events are said to be mutually exclusive if they cannot happen at the same time. They are mutually exclusive. They cannot. You cannot be in the class and out of the class at the same time. Okay? That is possible only in quantum states. Otherwise, it is not possible. You cannot use, you can either be here or out of here. So those are two mutually exclusive events. Okay? For example, how you perform in GATE exam and your attendance in the class are actually mutually independent. There is no relation. By mistake, you take that to be true. So you think that by absent being absent in the class, you will interrogate. Mostly the UG students, they think that by being absent in the class, they will study in the room and they will have high grade score. Okay, they fail. Then they are actually independent. Okay. Then conditional events. What is the conditional event? Point number 6. Right? Conditional event is 6 होगा था. 6. Mutual exclusion was 5. Right. Conditional event. So what is conditional event? Are those which occur conditionally on the occurrence of another event. So you write especially this formula. Okay. For example, PAP. If line 2 fails, what is the probability that line A will also fail? Line 1 will also fail. Okay. So we have given one event and we have to find out the probability of something else which is dependent on this event. These are not independent events, these are dependent events. Okay. Is the probability of event A occurring under the condition that the event B has already occurred. Okay. And the formula for this is P A given B is equal to P A intersection B divided by B. Okay. If these two events are independent, in that case, PA intersection B is equal to PA into B. Divided by PB, so it becomes PA only. That means P of A, provided B has happened, is simply equal to P of A if both are independent. It has no dependence on B. Okay. Right? Okay. So this is called conditional events. Next is simultaneous occurrence of events. Now two events A and B are occurring simultaneously. So what is the formula for independent events? It will be simply PA into PB. Okay. And for dependent events, it is P A conditional B into B. Okay. So that is simultaneous occurrence of events. So this is point number 8. 7. So simultaneous occurrence of events. Okay. Point number 7. Then the addition formula. Okay. Suppose A and B are two events. What is the probability of occurrence of at least one of the two events? Okay. Which is PA union B. That is PA plus PB minus PA intersection B. You know, occurrence of at least one event. Now this is the next formula which is given here. This we are going to use while evaluating the transmission system reliability. Okay, this formula. So this formula, as it says, PA is equal to I is equal to 1 to N P A conditional BI PPI. It also known as Davis formula. What it says, probability of event A occurring is equal to probability of A occurring given B1, okay, into probability of B1 plus probability of A occurring given B2 into probability of B2 plus probability of A occurring given B3 into probability of B3. That means in this case the event A is dependent on B1, B2, B3, B4 up to Bn, all the events. So in that case we use this base for or summation formula, you can say conditional probability. Okay. So now then we will move to this. Okay, we will discuss this also. Before discussing the problem, we will discuss this. What is probability distribution? So it was, what is the point number? 9, 10. So last 10th point we will discuss what is probability estimation, in which we will discuss PDF, CDF, random variables. Okay. What is a random variable? For example, in power system, the uncertainty is represented by random variables. For example, what is that? So we start with what is a random variable. Example is wind speed. Wind speed V. It is a random variable. Why it is a random variable? Because it can take any value. Okay, you cannot discrete and continuous random variables. This is a discrete continuous random variable. Okay. Okay, this is a continuous random variable. Suppose today at 11 a.m. What is the other speed? How can we say that? It can be any number. 3 meter per second, 5 meter per second, 2 meter per second. Okay. That depends on the past history. How it has behaved. For example, they predict what is the temperature today. Temperature is a random variable. Outage of generators is a random variable. Okay. But that's a discrete one. Because it is either 0 or 1. Number of heads and tails in a toss. That's a random variable. Discrete one. Either head or tail is a random variable. Okay. So what is random variable? The empirical determination of data is unlikely to lead to a single precise known value of probability. Okay. So that means the probability cannot be precisely known. Okay. For example, I will say what is the probability that today the temperature will be below 50 degrees centigrade at the night. I cannot give a precise number. Yes, it will be below 15 or yes, it will be above 15. Okay, I cannot say that. Okay. But I can say that it is 90% probable that the temperature at tonight will be less than 50 degrees centigrade based on the past data. Okay, so that's why this temperature is a random variable. We cannot give a fixed precise number for that. And a whole range of outcomes may emerge. Okay, so you have got a range of outcomes. The probability of temperature below 50 degree tonight can have various values, 90%, 80%, 85%. So that's why it is a random variable. Okay. Next, the parameter of the event being measure of a variable that varies randomly in time. Okay. So the parameter of the event being measure as a variable that varies randomly. The parameter that varies randomly in time and space. It can be discrete or continuous randomly. So you can write down an event may be represented by a continuous or discrete random variable. An event may be represented by continuous or discrete random variable. Okay. Now, then I told you about PDF and CDF. Okay. Probability density function and cumulative distribution function. Now the event that we considered is how many hours in a year? 8 Okay. Suppose it is 0, 1, 2, 3, 4, 5. How many hours in the year the wind speed was between 0 to 1 meter per second? Suppose it is say 100 hours. So the frequency is 100 by 876. Okay. So for that particular wind speed range. Okay. Now we can take the mean of that or average of that to represent that interval. So this frequency when you plot with the the event is known as the frequency distribution. Okay. Now if you connect it to a continuous curve, okay, then what you got is known as the probability density function. Okay. The mathematical representation is known as the probability density function. Okay. Whereas if you make it cumulative one, for example, what is the probability that the speed was below 2 meter per second? That means it is the summation of in 1, 0 to 1 as well as 1 to 2. Okay, so you sum that. So 0, 1, 2, 3, 4. So you sum, continue summing up. And when you connect it continuously, you get the cumulative distribution function of the CDF. The formula is that the PDF is given by dfx by dx. Okay, the differential of the CDF, cumulative distribution function. In other words, fx or the cumulative distribution function, also known as only distribution function, is given by the integral of the PDF. Okay, up to the random variables you are being concerned. Now it's a discrete variable, so in that case it will be summation instead of integral. Okay, write down these formulas. So under probability distribution we saw first random variable, next CDF and PDF. Okay. The first part was random variable, next CDF and PDF. The third part is expectation, which is simply mean. You can say that mean. Okay. What is expectation? It is actually mean. So the formula for expectations is Ex summation I is equal to 1 to n xi pi if it is a discrete variable. Otherwise, for a continuous variable it is a integral. Similarly, the variance is given by the dispersion around the mean, as we have seen in the last subject. Variance of the variables. Variance describes the amount of spread or dispersion of a distribution around the mean. So variance formula is given by this. And standard deviation is the square root of variance. And standard deviation is the square root of variance. Right? That we have seen in the last subject. Okay? So under probability distributions, these are the things that you have to understand. Random variable, PDF and CDF, expectations or mean, variance, or the dispersion around the mean. Okay? Then